You guys all ready for some Python? Awesome. Cool. Well, welcome back to HacDC, everyone. Today we're going to be covering program control and starting to use Pygame. So instead of just writing silly terminal apps where you can, like, you know, see console output and some numbers and stuff, we're actually going to be able to start programming video games, which is always fun. This is probably one of the more important classes that you're at. All the stuff that's being taught today is stuff you can use in pretty much any other programming language, with the exception of a few really weird ones. But yeah. All right, so today we're going to do Python goodness first. We're going to cover if statements, while loops, for loops, and the continue and break statements. And then we're going to do some Pygame goodness. I'm going to show you how to initialize things so you can actually get things up and running, how to make a screen, and then how to start drawing shit. Word. You can draw whatever you want. I'm going to be drawing shit. You can draw whatever.
Capital shit.
Cool. So, let's just dive straight in. If statements are a way of controlling your code. So you control the flow of your code by a few different structures. You have loops and you have conditionals. An if statement is a conditional. There are a few different varieties. You can do an if statement, you can do an if-else statement, or you can do an if-else-if, else-if, else statement, right? And they're just kind of variations on the same theme. So if a given piece of code evaluates to true, it will execute things underneath that if statement. If it does not evaluate to true, it'll jump to an else cause. Or if there is no else cause, it'll just jump to the next point in your code. Python, I didn't mention this before, but Python is a tabbed language. In order for you to have proper syntax, some of you have done Code Academy and things like that, so you know that you wrap if statements in curly brackets, right? You can wrap them in curly brackets, or you can put them on the same line, things like that. Python, you can't do that. When you use an if statement, you must indent the parts of it, right? So this up top here is the conditional part. So say if 1 does not equal 1, that's your test, right? So we're saying if 1 does not equal 1, that evaluates to false. None of this happens. This print does not execute. What I'm talking about when I say tabs is right here in front of the print. This absolutely has to be a tab.
So in order for everything to get executed below the conditional statement, it has to be tabbed over.
Correct.
Okay.
To the same indentation. If you don't tab it the same amount, it's going to yell at you. There are two schools of thought. You can use spaces or tabs, right? But I prefer tabs, and you cannot mix the two. So if you pick tabs and then switch to spaces, Python is going to yell at you. It will be upset.
If you nest, everything's got to be just right under the nested area.
Mm-hmm. Yep. Yep. So yeah. Generally people use 4. You can use 1. You can use 2. It doesn't really matter how many you use.
Technically, the language doesn't care, but the path for it says use 4.
Right.
How do I do it?
You hit the talk button, which is the big one, and then you hold the lock button. You're just supposed to hold it enough so people can get in the door.
Unless you want to talk.
And then hit the talk again to shut that off. All right. Cool.
Oh, so bad.
So the first little bit here is just a regular if statement, right? So we've only got the one conditional, and then we're never printing awesome because 1 equals 1. The second one is an example of an if-else. So if your x is greater than or equal to your x boundary, then you multiply x by -1. This is shorthand right here. The star equals means the same as x equals x times -1. It's just quick shorthand for that. You'll see that a lot in other people's code. So I wanted to show you guys that. This x is greater than or equal to x bound is actually something we're going to see in Pong later today, and like how the paddles hit things and how they work. Right. The third one is just another example of an if statement, but this time it contains an else if. So you can chain these things together. So if x is equal to a, print a is for apple. If else if x is equal to b, print b is for boy. Otherwise, print unknown with a sad face.
And I don't think you mentioned that, but there's two equal signs to check for condition,
Mhm.
and then one equal sign is an assignment.
Right, we talked about that last class, variable assignment versus comparisons. Yep. Any questions about if statements?
What is the asterisk and equal sign again?
So that's shorthand for x equals x times -1. And the plus equals is similar. It's x equals x plus 1. You can do that with any arithmetic operator. So you can do that with division. You can do that with the modulo operator, the remainder one we were talking about. I don't think you can do it with power, though. I think the star will not work. What's up?
I'm just noticing some syntax that I didn't have last class.
Sure.
Colon at the end of the, looks like only on the conditional lines.
Exactly. Yep. Yep. So, someone want to get that, please?
That's my question.
So the colon at the end of the line just tells Python to wait for an indent,
Oh, okay.
basically. So you're just like, all right, there's going to be more to this section, so go ahead and get ready for it. There are folding chairs out in the hall if you need them, or right there. Yeah, so we'll see that a lot now. So it's used for conditionals, it's used for loops, it's used for function definitions, it's used for classes. So you'll see that a lot. Today is the first class that we're introducing the colon. Thanks for that question. Any other questions?
Can you make, besides the colon syntax, is there another syntax just like using parentheses or curly Q things?
For what?
Like C or Java where you can use...
No.
You can't use
There are
that?
no curly brackets. You cannot do block syntax like that. Block syntax is done entirely with indentation. Yep. All right, so we're good there? Cool. The next thing I want to cover is while loops. So while loops just kind of execute the same code within the while loop as long as its given condition is true. So in this first example, we create a variable called x. That should look familiar from last time. And while x is less than 100, we print x, and then we add 1 to x. X plus equals 1 again is x equals x plus 1. The second example is a really fun gotcha that happens to all beginner programmers. If you don't update y, this will run forever. And it will always print 0, right? So you have to watch out for that, because if you're going to use a while loop, there's nothing like automatic that happens. You'll see in the for loop, which we're going to cover next, that there's some like cool auto magic things that happen for you. Yeah. While loops are less common than for loops, but they're super useful. And we'll be using them when we start doing Pygame stuff. Questions here? Yeah.
I don't know. I don't know if it's actually relevant or anything, but like,
Sure.
what makes it look again what x is after x has changed? You understand what I'm saying? Like after it's finished doing it and x changes, like what do you have to tell it?
It goes all the way back
again?
up to the top of the while loop,
Okay.
right?
Is that only for loops like this?
Only for loops like this. Yeah. So it'll like go, once it hits the bottom, it will go right back to the while line, and it will try the conditional again. In this case, it's x is less than 100, and it will check that again. So it'll go from the bottom to the top. Some languages have a do-while loop, like C has a do-while loop, where it does the check at the bottom. So once you're finished evaluating the code, it checks to see whether or not it should break out of the loop. But Python does not have support for that. Is that correct, Ben? Python does not have a do-while?
Yeah.
Python doesn't have a do-while, so you don't need to worry about that. But that is something it's common in other languages. So C definitely has it. C++ definitely has it. I think Java has it as well. Right.
The advantage of the do-while is that it'll at least do it one time.
Exactly, you got it. Yeah, whereas this will break at the top. If the condition doesn't match, it won't do any of the code. But the do-while, it'll execute everything once and then break out of the loop. Yep.
Why would you prefer that?
It depends on what you're trying to write. So like, here's a contrived example. If you're like trying to write something to a file, right? So you want some like text file on your hardware, and you want to like write at least something to it before you like loop back and write some more stuff to it. You could just like write the first like header of the file and then loop through and repeat some stuff at the end. We good with while loops? Cool. For loops are tricky in Python. I want to start by saying that they function a little bit differently than they do in any other language. In Python, a for loop will repeat a chunk of code for every item that is contained within a list. We're going to talk more about lists in a later class, I think next class. But for now, you'll just have to accept that a list is a list of things, right? It's more technical than that, but it's just a list of stuff.
It's like an array or?
Exactly. Yeah. For you Code Academy folks, a list is basically an array, but cooler, as it turns out. A list is an array, but cooler.
Okay.
Yeah, we're going to talk more about lists later. So in a normal, well, the normal for loop in other programming languages, you have to, I'll just skip it. Do it? Cool. So for loops in other languages, let me go ahead and pull up my terminal. For I equals 0, I is less than 10, I plus plus, right? This will look familiar to you guys who've done JavaScript or who have seen a bit of C code or something like that. This is a C-style for loop. And what this does is it creates a variable in the beginning called I, and then every time it'll check that second clause to see whether or not I is less than 10, and then it will do the third thing, which is the increment condition. There's a special term for it, but I don't remember what it is.
You need to declare I usually.
Well, yeah, I mean, whatever. So like this is the way it would work in a normal programming language. This would give you, instead of the item in a list, it will give you the index of the item in the list. This is different than Python. So back to Python. If we look at our Python code for I in range 10, what range 10 does, it creates a list of values 0 to 9, I believe. It works like that. So 10 things, 0 to 9. And I gets the value of the thing that's in it. So the first time through, I will get the value 0. The second time through, I will get the value 1, which would be the same in this for loop as well, just because of the way we put it out. But if we look at the second example of this for loop, for C and Apple, C is going to become A, and then C is going to become P, and then C is going to become P again, right? So it's, instead of giving you the index of what's going on, it's giving you the actual thing. People look confused.
So auto increment?
There's no index in Python, no index. So you Code Academy folks gotta throw that out of your mind.
So there's no way to increment more than just one at a time. Because like in that loop, you can, so
Exactly. Instead of doing plus plus, you could do +8 or something like that. There are ways to do that. You could look up range and see how range works, and range will actually show you how to, make a list of things that counts by 2s or by 3s or whatever like that. But that's kind of like the only way to do it. It's kind of sloppy in my opinion, but this is the only way you can do for loops in Python.
It's the third argument to range.
It's the third argument, so you have a start, a stop, and then an increment by argument, right?
The 10 is a count of what's in the range?
No, 10 is, so range is a function call, and the return of that function call gives you a list of numbers. Bang, Python, right? Oh, that's not working. So if we do range 10, we get a list, 0 through 9. The square brackets are the list syntax, right? So if we do a for I in range 10, oh goodness, print I, we do something like that, it's going to print every element, right? So it'll go 0, 1, 2, 3, 4, 5, like that, right? So if we just did something different, like A equals A, B, C, instead of getting indexes here, for I in A, print A. That was weird. Oh, print I, right. Print I, dangers of live coding. It prints the actual elements as opposed to the index. So that's the difference between normal languages and Python. Questions? People still confused? What's up? Still getting confused looks.
Can you show us what your examples
Sure. What were the examples? For I in range 10, hello times I. Oh, that's obnoxious. For I in range 10, print hello times I, right? There you go. You remember last time we talked about how you can multiply strings to get like multiples of the same thing that's going on.
And it's doing that because there's 9 iterations of it, so every time it goes into the next one, it adds on to it.
Exactly. Yeah. So each line is one iteration of the loop that we see there, right? And then
there's 0 hellos in the first line. You know what I mean? Because the first element is 0. So there's a blank space where there's just no
right,
hello.
exactly. And then there's 1, 2, 3, all the way up to 9. Right? And the next one is for C in Apple, print C. For C in Apple, print C. And that just prints each letter on its own individual line. Strings are considered lists for most purposes, so you can loop over a string as you would a list. There are other things you can loop over. We'll talk about those later. Is this helpful? Did this illuminate any issues with loops? For loops? For loops are still weird.
There is no traditional 3-argument or 3-step.
There is no traditional 3-argument for loop in Python. The only way to do looping in Python is like
so how
this.
do you increment, if you want to increment by more than 1?
We were talking about like range 0, 10, 2, right? We can do something like that. So it goes 0, 2, 4, 6, 8, and it's going to create you that list.
You can always do it manually, so it starts with 0 and goes to 10.
So there's this cool function when you're programming in Python called help. And if you type in help and one of the functions Python knows about and hit enter, it'll actually tell you what that function does. So in this case, I've been calling range and doing weird things to it. This is the actual definition of what range is. If we look right here, it'll say what arguments it takes. The ones in squares are optional, right? So the start is optional and the step is optional, but you need at least stop. What we were doing before is just giving it stop, and it would just go 0 to 9 inclusive, which is, 0 to 9. It would just use 10 to figure out how many numbers should be in there, start at 0 and count 10 up.
How did you call the help?
It's literally just a function. So if you do help range, and then, I think you need to hit Q to get out of that menu. But this is super helpful. The documentation that can be found here through the help menu is also online on Python's website. So you can see what's going on there.
When you start typing a function in idle, I just had it pop up a Visual Studio-esque perhaps a little help thing.
Yep.
So a little hint.
Yeah, definitely. Idle is nice like that. For loops, are we still having some issues? Is there any way I can help illuminate this more?
I got it, but it's locked up.
I agree. I completely agree. I'm kind of mad about the fact that Python doesn't actually have like a regular for loop in it, but this is the way they decided to do it for whatever reason, and their benevolent dictator said that's the way it's going to work. So that's it.
Is there a key shortcut to indent everything below the conditional statement the same? Like
That depends on what you're using.
Okay.
Mhm.
Your IDE.
Your text editor.
Yeah,
Yep.
okay.
If you have one required argument and 2 optional, if you use 2, how does it know which, if you want to start and stop, or if you want the stop and the
It goes left to right.
integer, or the increment?
It'll go left to right.
Okay.
So it'll
So
count.
the first two,
Mhm.
unless you use 3.
Exactly.
Okay.
Yep.
Can you use a variable instead of?
Sure. X equals 20, range X. That's fine. You can do things like that all you want. X, X, right? That doesn't give you anything, but you can, it's funny. That's saying count from 20 to 20, right? Yeah, so you can use variables for any place you would use a number, you can use a variable. Any place you would use a string, you can use a variable. Any place you want to use a Boolean, you can still use a
How do you
variable.
count down backwards?
That I don't know.
Start and stop.
What's up? Is that the way? Range 0, 10, -1. That doesn't work.
Do 10 to 0.
Cool. All right, that's the way you do that. I learned something new today. So for loops. Yeah, no, kind of makes sense. They make a lot more sense when you actually start using them. So when we talk about lists and things like that, you'll really see the reason why you want to be using lists, how lists are used properly, how for loops can help you iterate over the items in a list or a dictionary or whatever else we're playing with. So in later classes, you'll see why these are important. Cool. So continue and break. Continue and breaks can be used within loops to change the way loops behave. Continue will skip all the code beneath it and just go to the top of the loop again. And break will completely break you out of the loop and stop executing any code within the loop. Right? So in this first example, we have for x in Python. If x equals h, continue. Otherwise, print x. So that's kind of a silly example, because if we didn't have the continue there, it would stay. Let me just do it. For x in Python. And then what was it? If x equals h. If x equals h, continue, else print x, right? So you can see there it skipped the h, it just printed everything but. Because there's an else statement there, we could have had anything in place of this continue.
Right, consider the bottom half when we go on to the top. Anyway, because it doesn't execute else.
Exactly, yeah. So really a better example would be pass print x. Oh, I did that wrong again. Right, so that'll do that. If h, we do continue, and then print. I guess I will change that in the future. So what this one is actually doing is what I wanted the example to say. So when we say for x in Python, if x is equal to h, continue, it's going to skip the print statement and go to the top of the for loop, right? So this skips the else and like make sure that we just skip that h. This is the example that should be in my presentation that is not. So if we execute this, you can see it does what we expect. It skips that h. For our break example, we have this statement that uses the modulo operator. We talked about this being remainder last class. We're trying to see if x divided by 50's remainder is 0, and if it is, we're going to print 50 and then break out, right? So in theory, for x in range, let's do 1 to 100 just because it's nicer. If x mod 50 is equal to 0, print 50, and then break, right? So that prints 50 once, right?
You don't really need the break statement, do you?
So if we get rid of the break statement,
Print twice and do.
it will print twice. Guess not.
Try 101.
Right. Gotcha. Right. So this should print twice. Yeah. Yeah. So the break is just breaking a side of the loop once it sees the first 50, right? The first multiple of 50, then it prints something and just breaks out and then stops executing. Any questions about those two? Again, these are things like once you start using them, you'll see their use, right? So like you're playing with some sort of text file or something like that and you want to skip line 38, you would have some sort of continue. You'd be like, if the line number equals 38, continue. And then just like continue dealing with your file, something like that. But yeah, you just got to play with them, see how they work. Questions about Python things before I talk about Python or Pygame? Nope. All right. So I am supposed to say something about being a game library and something about this being wrappers for a C library. I'm going to change that for next class. Cool. So Python is or Pygame is a library, and what a library is a collection of functions that allows you to do something that Python can't. So in this case, Pygame is specifically allowing you to draw to the screen, play with keyboard, mouse, joystick events, play sounds, play with images, things like that. What this really is, like at the bare metal, is a collection of C functions. C is a different programming language, and they just kind of like wrap that in some Python and then distribute that as Pygame. And that's the way this thing works.
Now, why did they choose to do that in C?
Because anytime you want to deal with hardware, you generally do it in C. And that's just the way it works. Pygame is technically a wrapper for SDL, which is the simple direct. No, it's some media library. I think it's simple direct layer or something like that.
Simple direct media layer.
Is it?
Yeah.
Simple direct media layer, which just allows you to get easy access to the screen and to hardware and stuff like that. So what Pygame is just a wrapper for all of that C library that already exists. People have made it into a Python library and then distributed it as Pygame. Which part? The whole thing?
I don't think I followed that at all.
All right. So we have these. We have a piece of hardware and we want to use this piece of hardware. A lot of the times when we.
Besides our computer.
On your computer.
I'm being
Like your computer
very
screen
dense.
is a piece of hardware.
Oh, you're okay. So,
Yeah.
Okay.
Your keyboard is a piece of hardware. Nope. Nope. Just all the features that your computer has. So your display, your keyboard, your mouse, your speakers, everything like that. When we want to talk to those devices, we generally pick a lower level language than Python, just because of some like issues that hardware has. When talking to hardware, you need to take other things into consideration. So people wrote a collection of functions, a bunch of programs that you can use in order to allow you to access those features.
Okay.
Mm-hmm.
Thank you.
Yep. Any other questions about that? Nope? We're cool? All right. So the first thing you got to do when you start doing Pygame stuff is initialize Pygame. And to do that, you use these 3 lines, always. They're always the same. It's just kind of like this magic incantation that makes everything work. So for those of you who may or may not have Python installed, I was telling you all to type in import Pygame, right? And if it said nothing, then it worked. And if it said something, then it didn't.
Nothing is better than
Exactly, in this case. That is just grabbing all of the collection of functions that you have available to you within Pygame and throwing it into your Python environment that you're working in. And then this from pygame.locals import star, that gets you some constants that you use. So like keyboard things, so keys you press on your keyboard have special names in Pygame and other things like that. That's just saying everything that's contained within this local folder, pull it into your current Python environment. I'm not super surprised to hear that, actually. Yeah. And then the Pygame init, just make sure that your sound is working, your display is working, your keyboard events are being captured. It does all of that stuff for you.
That line returned a couple of values.
Yeah, I got 6,0.
6,0. I believe that. All right. Python. Oh, I'm already in Python. Import pygame help pygame.init. Alright, so this initializes all of the imported pygame modules, and yeah, it tells you the numbers that passed and the numbers that failed.
0 at the end is good.
Yes, 0 at the end is good. Now we know. Alright. The next thing you need to do in Pygame is to set up a display. I have a bunch of sample code for today, so I'm going to go over that in a minute. So if I go by this too quick or it doesn't make any sense, you'll see it actually in action, and it'll help out a bunch. So you need to create a display, you need to pick a resolution and a title, or you can make your whole thing full screen. I don't suggest that right now because I'm not teaching you how to gracefully exit things, so you're going to have to force quit at the moment. And then you have to flip the screen to update. Now flipping screens is kind of a weird concept. When you have a computer, it has like 2 places you can draw. It's basically like this magic flashcard you have, and you draw on the front of it, and you flip it over, and then this side is magically clear, right? So you like draw on this side and flip it, and then draw on this side again and flip it, right? And you continue to do that to create some sort of animation. So it's like this weird magic flip card that you can just continually flip, and it will clear one side of it, right? Again, that'll make more sense when we start looking at what's going on.
It's double buffers.
Yeah, Pygame is double buffered by default. You hit talk first.
Brad, we're doing this in the,
Alright,
doing this in
whatever.
the command line?
What's up?
We're doing this in the command line? Or
I'm doing it in the command line. Alright, so Pygame also comes with awesome draw functions. So you can draw shapes and lines. All of the documentation can be found at that website. I'll pull it up in a sec. So you can draw on the screen using rectangles. You have to specify the screen and some other arguments there. And then you flip the display to actually see what's going on. So if you don't flip the display, you won't see anything. But when you flip it, you'll actually see what you've drawn. So that's Pygame docs ref draw. Ref draw.html. Right, so here we were drawing a rectangle. So it takes a surface, which in this case is our screen, a color, a rectangle, and a width. Right, so you have a bunch of different draw calls. They're all documented on this page, so you can draw a polygon, a circle, an ellipse, an arc, whatever you need to draw, you can go ahead and do that. That was the super quick version, mainly because I just wanted to actually show you the code. So let's go ahead and run this Pygame pretty picture code. Right, so if I run this, this is our first little Pygame thing. It makes another little house, because I like houses as demos. It doesn't do much but create a little screen for you, and then draw a triangle, and then draw a rectangle in 2 different colors. Relatively simple. And it's using Pygame to do that. So if we look at the code, you'll see a bunch of the stuff we just talked about for Pygame, including one of those while loops. That's nice. So in the beginning here, you can skip this first line. That doesn't really concern you guys. And we have our import Pygame from pygame.locals import star and our Pygame init. Those are all part of that magic incantation you need at the beginning of every Pygame thing you do. We also have a resolution, and in this case it's just, this is what's called a tuple. We'll be covering this more next class, but it's just a series of values. It's like an array, but worse. It's got a more specific use. I'll talk about that more, but for now it's just 2 values stored in one variable. First thing we do is we create our screen, and to do that we do pygame.display set mode resolution. And resolution is the value that we had up above, where it took these 2 parameters, 200, 200, which makes our screen 200 pixels by 200 pixels. The next thing we do is draw our house. So we do a little bit of math on the first element of the resolution and the second element of the resolution to try and figure out where the middle of the screen is. the 0 and 1 there. It was like when we were talking about grabbing each character from a string, how you could use the square brackets to do that. You can do similarly with tuples, and you can do similarly with lists. We're going to talk more about that again later class. Then we draw rectangles using that call that we saw from the Pygame documentation, where screen is what we're drawing to, and this 255, 0, 255 is the color. And then box X, box Y, 50, 50. That would be the X location, the Y location, the width, and the height. Pygame just likes things to be in tuple form, so you just have to conform to whatever they want. So colors are done in tuples with 3 values in them for R, G, and B, and rectangles are in tuples with 4 elements in them, 1 X, Y, width, and height.
So I know what an array is. I have no idea what a tuple is.
Right. So an array, or a tuple is an array but worse, and I'm going to talk about like what that means in a later class. The differences are really subtle, but they're pretty important. So I think next class we're covering data structures. So we'll talk about dictionaries, tuples, lists, and sets, I believe. So that's my hand-wavy explanation. If you really want to know, you can go to Python's documentation website, right? And you could look up maybe it's not there. Tuples. Just do something like that, pull up tuples, and check it that way. Yeah. But I'm gonna punt that one for now. So after we draw our polygon, or after we draw our rectangle, we go ahead and draw a polygon. This takes a list of points. So we're creating a triangle by giving a list of points. This is our list right here, which looks a little weird because we haven't covered lists yet. So the square brackets denote a list, and every comma in between is an element in the list. In this case, we have 3 elements. Each one of them is a tuple with 2 items. It's complicated. This is a crappy example. And then we flip the display. And then the reason you're getting the spinny beach ball of death is because we throw everything into an infinite loop and just wait until someone actually kills the program.
Well, I think that's maybe calling out just trying to, or not,
When you do pygame.init from your Python shell, yeah, that's expected as well.
Oh, okay.
You have to kill Python in order to get rid of your spinny beach ball of death. Right, so that was the quick version of that code. The other code, I think, is nicer. So one more time, just for fun. Pygame, pretty picture. Just gives us our little house. You'll notice this time that it does everything instantaneously. Basically, you cannot see it draw it, it just happens. Right? You'll notice that you don't really have a pen anymore. You're just kind of like sticking things to the screen as if they were like giant stickers or something like that. So everything you start drawing is going to happen pretty much instantaneously versus the little turtles that kind of wandered around the screen. It's different in that regard. So the next piece of code that I wanted to go over was this. I mentioned before that we're going to start programming Pong, and through each class I'm going to build on the materials of the previous class and show you what you can do to make this Pong game better. This is just a little example of showing the Pong paddle physics, right? Physics. So you see when it like, yeah, right? Like Hack Manhattan. Yeah, they're way cool there. Yeah, so this is just hitting the ball, hitting the wall, things like that. Yeah, so let's go over the code. You see what it does. Pong paddle hit, right? So again, this first line is not required. Any line that starts with a £sign is a comment and does not get evaluated. These 3 quotation marks are what's called a doc string. You can have those at the beginning of your file, and that will explain what the file does. This is how the help menu that you have in Python is populated. So if you want to have help functionality for your custom-built code, you would need to use doc strings for different things, for your modules, for your functions. So we just threw something simple up there just so you guys could see an example of that. I keep saying we because I taught this class with someone else last time I taught it. That's why. So again, we have our import pygame from pygame locals import star, and then we have pygame init after we create some variables. Again, it's the same magic incantation. This time we have 3 variables: screen width, screen height, and the frame rate at which things are going. We create a clock, because if you don't create a clock, everything moves stupid fast, right? So the clock limits the speed at which your animations go. If you don't have a clock, it will go as fast as your computer can handle, and generally that's really, really, really fast. So you wouldn't even be able to deal with it. For funsies, let's get rid of it. So if we get rid of this, and we get rid of this, and rerun the code, oh, that's not terribly fast. But you see it's much faster than it was before.
So if you adjust the speed or just
that's as
move it down, that's all.
you can definitely adjust the speed. But what we were doing is just getting rid of the clock, so it doesn't really know the difference between frames. So we don't have a constant frame rate anymore.
Okay.
It's just going as fast as it wants to, and that varies on the screen size. So if I resize this, if I can resize this, no, I can't. So if you resize that screen, it'll go faster because it has less to draw, and it's really kind of weird. So you always want to try and have some sort of counter so you know how many frames you're elapsing by. Back to the code. All right. So we make our clock so we can tick everything and make sure stuff works. We create a screen like we did before. This time we use screen width and screen height as opposed to just the resolution tuple. We actually just created a new tuple in this case. The double parentheses are kind of confusing. The innermost set of parentheses are for the tuple, the outer set are for the function itself. Does that make sense? We set the caption of the screen, so the window itself up here, we'll just say Pong Paddle. Then we create some variables that we're going to be using for where the paddle is. And the paddle X position is 20, the paddle Y position is the screen height divided by 2. We're going from looks like we're going from the center of the paddle. We create the ball, and we throw it at screen width divided by 2, screen height divided by 2, so that should be the middle of the screen. And then we give it its speed. Its speed is 1, so it moves 1 pixel per click of per tick of the clock. Then we go ahead and make our background, fill it with nothingness. Then we go ahead and start doing our little game loop, right? So while true, so this will run forever, we tick the clock, and that'll make sure that there are 30 frames in every second. It does that magically for you. We blit black to the background, which just basically says take a bunch of black and just stick it, so it clears the screen. Then we draw a rectangle, and then we draw our ball. Then we change our ball's position, and then if the ball reaches the end, here's our if statement from before. If the ball reaches the end of the screen or it hits the right, if the ball reaches either end of the screen, it's going to reverse direction. So if the paddle does not hit it, it will hit the other side of the screen in reverse direction. And then we have another if statement that says if the ball hits the paddle, then we want to bounce back, which is again flipping the direction. And then we flip the display so it continues to animate.
So if you didn't do those last two, the ball would just travel off the edge of the screen?
Which last two? These last two?
The one where it's bouncing back? Like you just wouldn't see it anymore, but in the program it would still be traveling?
Correct.
Okay.
Yeah. So if we comment this out and put a pass does nothing. When you have an if statement, there has to be something underneath it. And if there isn't, it will error for you. So if you want some sort of placeholder, you just use the word pass. But pass literally does nothing. That's its only job. It's a placeholder. So to answer your question about reversing, we can just get rid of that stuff and let it go. It's going to go painfully slow until it goes off the screen. We'll never see it again. And that's what's going to happen. Yep. No big surprises there, but yeah. Yeah. So the times -1 is just reversing the direction on it. So it'll travel in a given direction.
Determines the collision point by the edge of the object as opposed to the center.
So if you look here at this if statement right here, there's like some math going on there, and the math is just to try and figure out. So we know the paddle is 20 wide total. We take half of that, and we try and make sure, right? So we add the radius to we subtract the radius from the ball because we know it's going to hit on a certain side, and then we add the paddle's width. So so this accounts for both the side of the ball and the side of the paddle, not just one or the other. If we got rid of all that complex math, it would just wait until it hit like the middle of the paddle, so it would like go into it a little bit.
So you have to define it.
Exactly. You got to do some math on your own in order to make sure you know what's going on
You can
there.
set a variable to do that all at once.
Absolutely. Yep, absolutely. You'll see as we go on, these files are going to get more and more refined and less crazy looking, so it'll look a lot cleaner by the end. But yeah, this is about all I had for this class. Does anyone have any other questions for anything we covered today? No? I'll be sticking around for like an hour, so if you guys have issues with Pygame or Python in general, or you want to talk to me about programming other things other than Pong or silly houses, go ahead and ask me. Your homework is to, what was it? Make an animation of sorts. So draw a picture using Pygame and then try and move bits of that picture. Yeah, that's it.
Is that code available somewhere?
Yep.
Maybe you said that once.
It's the, so it was on the GitHub account that I showed last class. Just
There's links in the wiki page.
that don't work. Right. So let me just pull up that website again. This website is going to help you a lot. The Pygame documentation website, that'll tell you how to call all of the functions, what arguments they take. And there's a bunch of tutorials on here too as well. So if you want to do something that you don't know how to do yet, you can go ahead and go here and try and figure it out. There's also this Python language documentation, which can be found at docs.python.org, and that will tell you everything about Python. And it is a huge amount of stuff, and it is really difficult to read. Well, I mean, it's really difficult to get through all of it. It's written in a really nice way. But that'll tell you everything about the programming language and all the features of all of the things that we're going to be using in this class. So those two websites are really good to know, really important. And the GitHub account is mine, and where is it? Here. And once again, this is the site for the Intro to Programming class. All of the code and presentations can be found there. So, yeah, that's all I got.
I think you said last time there was a mailing list, but you didn't know what the...
Yeah! Ben, how do I look at mailing lists?
Let me see if I can figure that out. That's Chris's thing.
Well, Chris is in the other room, right?
Yeah.
All right. Cool. Answer for you in a second. Other than that, we all good? It says github.com/3lawssafe with 1 S /HacDC. Does that help if I make it orange? All right. Yeah, no problems. Do you know? I think Chris made one. Yeah, prog101 at hackdc.org. I believe it's there, but I don't know how to actually sign up for it. What was it? It was dc.
What's the name of the list?
Prog101. Should I grab Chris? I'm gonna grab Chris.
Yeah.
Cool. I'll be back in a sec.